This session is on method overloading. Let's say you have a driver for your car and you use your driver to travel to many places. So let's say you are going for a restaurant, you're going for office, you're going for school. So you use driver for going to different types of places. You can use the same driver basically to travel to more than one place. Like you can ask him to travel to first go to a school and then go to a restaurant. So you can even make him to travel to multiple places. Here we are not using different drivers for traveling to different places. We are not hiring different drivers, right? So the same driver is overloaded to perform or to travel to any number of places or any types of places. This is exactly what Java overloading means. Overloading is a concept where we are overloading a method. We are using the same name for the methods, but the methods can receive different types of arguments or different number of arguments. So let's see that with the help of a program. So I'm going to create a class. So I'll name it as some test. Okay, so we are going to do addition of two numbers. For that I'm going to write a method. So I'm going to write a static method, static void, name the method as sum, and it is going to receive two arguments, integer a and integer b. Inside that we are just doing a sysout, and the sysout is going to have just to name it as two integer addition, two int addition, and followed by a plus b. So all that it is doing is it is adding we are passing two input arguments, which those two are integers, and we are just adding those two numbers. Now if you want to call this, how do you call this? You'll just say give sum 10 comma 20. So this is going to basically invoke this method. So we are passing two integer arguments, and it's going to get this method is going to be invoked, and it is going to perform the addition. Okay, now if I want to add three numbers, what I will do, I will be writing a different method for that. So I'll be using a different method, and now I need to name this method as sum 3 integer. So because I'm adding three integers here, so I'm going to make it sum 3 integers int c, and make it as 3 integer addition, and make it as a plus b plus c. Now if I want to make 4 integer addition, again I need to create a new method. That method name will be sum4int and do it. Like if I want to do 2 double addition, I will make one more method sum2 double addition and then do that. So what we are trying to do here is we are trying to make the method name unique. If you have the same method name, it may not work. So we are trying to make the method name as unique. So the person who is going to use your function, like here I'm calling this function, right? They have to remember, if I want to add three numbers, I need to call sum3 int. If I want to add two doubles, I need to call sum2 double. Like that, they have to remember your methods basically in order to call that. That is not a very good idea, because what you're doing actually is just trying to sum the numbers. The caller of the function does not need to worry about whether they need to add in integers, or whether they need to add two numbers or three numbers or four numbers, or whether they need to add two doubles. All that they need to do is addition of numbers. Whether it can be an integer, double, they don't care. Whether it can be two numbers, three numbers, four numbers, they don't need to worry about. All that they need to remember is only the method called sum. What is going to be different is either the type of the arguments or the number of the arguments is going to be different. So this is what exactly we talked about in another example. Like you will be using the same driver, you'll be overloading that driver with different types of input, different types of places where you want him to travel, or different number of places you want him to travel. So that is exactly what we are trying to take it over here. We are going to use the same method name. We are not going to change this to sum3 int. We are going to make it as sum itself. So here we are saying I'm going to use the same method name, but the number of arguments or the type of arguments is going to be different here. Okay, so the same method name can be used. If you see here, what is the difference between these two methods? It is having one more argument here, right? So I cannot have a method like the same way. This is now the compiler is going to make a problem, because you are passing two integers here as well. You are passing two integers and the name of the method is also same. So this is not correct. You cannot, if you call some 10 comma 20, which one I will call among this? I would not be knowing that. So this is not right. So you may have to either change the number of arguments, either include one more integer or float, whatever it is, or change the type at least, so that I can distinguish between this method and this method. So you can ask me, can I distinguish by making the return type different? Say it is returning an integer and say it is going to be returning a plus b. So now these two are different methods, right? Because first one is the return type is void, that is not returning anything. The second method is returning something. So now these two methods should be different, but why it is still complaining? So Java does not work like that, because when you even take the same example, now you are calling sum of 10 comma 20 here. If when you're calling this method, now the compiler has to decide whether it has to go and call this method or this method, because both are having two integers. I don't know, I don't care about what is getting returned here. Okay, so it is up to the program to, even if I don't have this method, it is not my problem to receive this. Actually, it is not mandatory that I have to get the return value and work with that return value. I can still call the method without caring about my return value. So what is the thing is, we don't care about the return value, and this is not a overloading. Overloading means you have to either change the number of arguments or the type of arguments. Just by changing the return type, you cannot overload a function. So it does not care about the return type. Basically, it is mandatory that you have to change the number of arguments or the type of arguments if you are going to use the same method name here, if you are going to overload the sum method here. So I'm just going to remove this, and let's talk a couple of more examples. So let's say now I'm going to have one more method which is going to take, instead of integer, it is going to take 2 bytes. Okay, so I'm going to change it as 2 byte addition. So now what will happen if I use sum of 10 comma 20? Which method out of this is going to get called? Of course, this method will not be called because it is expecting 3 arguments, but I'm just passing 2. So out of these 2 methods, one of them should be called. So which one is matching with this? So you can see, like, I have 10 comma 20. 10 is a so the byte range is minus 128 to plus 127. So of course your 10 and 20 is within the range. So should it be treated as byte, and it is going to call 2 byte addition? Our expectation is like that, but it may not happen like that. I'll just run this program just to show you what is the result. So it is not going to call 2 byte addition, it is going to call 2 integer addition. We'll see why it is not calling this and why it is calling this, even though it is within the range of bytes. By default, Java is going to take whatever numbers you are going to put here as integers. So it does not consider them as bytes. If you want them to consider them as byte, you have to cast this into byte. So the moment you cast this into byte, this 10 will become a byte. Otherwise, it is going to be considered as integer. Now tell me what is going to happen. Is this going to call now 2 byte addition or 2 int addition? Let's run this program. It's still going to call 2 int addition. Why? Because I converted the first one to byte, but the second one still remains as integer. So if at all I'm just matching with this method, what will happen? The first variable will match with this byte variable, but the second one is integer. So you cannot fit an integer into a byte container. So integer is 32-bit and the byte is just 8-bit. So you cannot have a bigger object pushed into smaller object. It will not do the automatic casting. Actually, if at all I need to do, I have to manually convert this number and do it. It does not do a automatic casting. So integer is a bigger number, and you cannot put that into a smaller container by default. So if at all you need to call this byte, you need to again cast it into byte, and then now if you invoke it now, the closest match is byte comma byte. So now it is going to call the byte addition, because this is byte, it has no reason to call integer because it is exactly matching with this method. So it is going to use this one. Okay, let's try to write a few more methods. have something like, instead of byte, let's try to make it as double, this as well, and change this to double addition. Okay, so now if I call now sum of 10 comma 10, what's going to happen? Of course it is going to call, this is an integer, this is an integer, the closest match is this, and it is going to call 2 integer addition, which we are aware of. Okay, so this is good. But if I change one of them as double, let's say instead of 10 I'm making it as 10.0, now what is going to happen? So here it is not going to call integer, even though this first one is matching with integer, but the second one is not matching with integer, it is a double. So you cannot fit a double which is 64-bit into an integer which is 32-bit. So of course it is going to call this method, double comma double. So that's how this function overloading works, and it automatically casts and matches to the nearest method, nearest to possible data type. So it is basically using the same method name for different number of arguments or different types of arguments.